myself Paranjoti Karthik from Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic Uniform Cost Search UCS. Uniform Cost Search is an uninformed search algorithm is used to find the shortest path from start node to goal node or end node. It is unlike of breadth first search, where breadth first search uses a uniform cost for all the edges. Here, different edges uses different cost. It means every edges have different values. It always expands a node with lowest cumulative path cost. Before that, we have to familiar with the cumulative path cost. Cumulative path cost is nothing but uh, adding the current edge value with previous edge value is known as cumulative path cost. The lowest of that of those multiple cumulative path cost will be said to be lowest cumulative path cost first. Every searching technique uses data structures um, like BFS is using queue and DFS is using stack. Here we uniform search cost search uses a priority queue. Priority queue in the sense means priority queue will store cumulative path cost first values in the queue. Here nodes are arranged by cost, not by the order of insertion. Let's directly jump into the algorithm. First, every start node will be pushed into the priority queue with the cost of 0. Then the start node will be expanded. If the expanded node have any values, the cost of the current edge is calculated with the previous um, starting node, which is 0 here. 0 plus the current node value will be stored into the priority queue. Until the priority queue becomes empty, the following operations will be performed. Um, so we will be calculating all the node in our priority queue, and the lowest cumulative cost will be removed and uh, removed from priority queue and added into a visitor node. Uh, if it is a if the goal is found, if the goal is reached or attained, then the solution is found. Then we will be coming out of the loop. Next, we illustrate the uniform cost search with one example. This is our sample graph for illustrating the uniform cost search. Now, the letter inside a circle are said to be node. The connection between or the line connects two nodes are known as edges. The value behind the edges are known to be cost of the edges. As per the discussion before in the algorithm, uh, we will be having one queue which is priority queue. So, and also a visitor. The first step is the starting node will be your the starting node will enter into the priority queue with cost of 0. This is our first step. Then the next step, we will be expanding the starting node. Along with that, we will be calculating all the traverse through all the nodes. So there are two edges. They are B and C. So we are exploring the starting node. Now we will calculate this cost. The cost of the uh, starting node is 0. So 0 plus A to B, the distance is 2. 0 plus 2, we will be getting the 2. And 0 plus 3, we will be getting 3. Okay. Yes. So the third step is we will be finding the lowest cumulative cost path. Once if a node is becomes visitor, then strike it out and write it under visitor. Now we will be calculating the lowest cumulative path cost between the remaining nodes, which is not from the strikeout. There are two values. They are B and C. So which one is having the lowest cost? B is having the lowest cost. So then we will be traversing along with the B now. So there are check if any node is from B. Yes, there are three nodes. They are D, E, and F. So we are writing what are the costs. Now we will be calculating the cumulative path cost. So the meaning of the cumulative path cost is adding the previous node value, sorry, previous edge value with current edge value. So previous edge value is 2, yes, 2 plus 1, which is 3, and 2 plus 2, which is 4, and 2 plus 3, which is 5. Okay, so now B gets visited. So let's strike it out and make the B as visited. Now we will be checking the lowest cumulative path cost from this. So there are two values with same cost. So actually in priority queue, who is added the first will be considered as a first one. Okay. Now we will be traversing with C. So there are two nodes. They are G and H. So let's find out the lowest cumulative path cost first. So the distance is 3, 3 plus 1, which is 4, and 3 plus 2, which is 5. So make now we have visited the C. So let's strike it out and add it into the C. Okay. C into the visitor. Now we will be calculating the lowest cumulative cost first, path cost. So 3, 4, and 5, 4, 5. So the lowest value is 3. So which have whether D has any node below it? No. So it is a leaf node. So we can we can stop the execution there. So taking out the D from priority queue and add it into the visitor node. Now we will be checking in the next process, lowest cumulative path cost. So the next lowest cumulative path cost is 4, 5, 4, 5. So E and G have the same values. Even though E have the first priority, we will be traverse through the E. Okay. Next. So what are the nodes we are have below the E is I and J. So directly we write I and J. Okay. So now calculate the cost of the. Okay. Until that E we are having 4. 4 plus 3, which is 7, and 4 plus 1, which is 5. Okay. So now the E is got traversed. So removing from the queue, priority queue, and add it into the visitor node. Next, we will be looking into the lowest cumulative path cost. So checking 5, 4, 5, 7, and 5. So 4 is the minimum value. So which has the G. G, if there is no node below the G, it is a leaf node. So directly we are taking it from the priority queue and add it into the visitor. Now we will be going traversing it into next lowest cumulative path cost. So 5, 5, 7, 5. Even though there are three nodes with same value, the first node in the queue will be have the higher priority. So F is our node first. F has one node which is k. So we will be writing it here k, and what is the cost of it? 5 plus 2, which is 7, plus 5 plus 2, which is 7. So after visiting the f, we will be striking it out and add it into the visitor. Now we will be checking the other cumulative cost first, path cost. So 5, 7, 5, 7. So 5 is the minimum. Even though there are two values, the higher priority will be who is having the first. So let's traverse along the H. So H has two values. They are L and M. So L and M. So now calculate the distance between until H, our cost is 5. 5 plus 3 we will be getting 8, and 5 plus 1 we will be getting 6. As the H is got traversed, so taking out from the priority queue and add it into the visitor. Okay. Now we will be checking with the lowest cumulative path cost I, J, K, L, and M. So 5 is the lowest one. So we will be traversing along with the J. To J, there is no node below the J. It is a leaf node. So directly we will be taking the J from priority queue and add it into the visitor. Next lowest cumulative path cost, which is 7, 7, and 8, 6. So the lowest value is 6 with M. Let's check. M don't have any node below it. It is a leaf node. So remove it from the priority queue and add it into the visitor. Now we will be checking uh, from this I, K, and L. So I, even though I and K have same value, I have the highest priority because as it added it firstly. So check the I. I don't have any nodes below it, and it is in a leaf node. So taking it out from a priority queue and add it into the visitor. So next we will be checking into K and L. So directly we can say that K is the smallest value. So checking for the K value. So the double circle of a node represent it is a final node or it is a goal node. So now we finally we traversed into the final node. Okay. So taking out from the priority queue and add it into the visited node. Now the L value with 8 node will remain same. Once we found our final node or goal node, then we will be stopping the execution and coming out from the uh, process. And this is how our UCS or uniform cost search will work. Finally, we will be getting the result of A, B, C, D, E, G, F, H, J, M, I, K. We can now calculate the path cost of this. Okay, 2, 3, and 2, 3 so 5 and 7. So the cost is 7. So thank you.